Alright, so we just tackled arithmetic series, and now we're working on geometric series. So we remember from our geometric sequences unit that a geometric sequence is one in which you can multiply the same number each time in order to get the next term, and that number was called the common ratio. So a geometric series is really similar, except instead of having those commas, we have some plus signs and we can find some sums. So if I'm looking at 2, 6, 18, we know this is a geometric series because I'm multiplying by the same number each time to get my next term. 2 times 3 gives me 6, and 6 times 3 gives me 18. So here it is in sequence form. I can write it in series form as 2 plus 6 plus 18, and I can find a sum there. So just like with arithmetic series, rather than having to write out the whole series and add them together, we have a couple of formulas that can be useful to us. And it doesn't really matter which one of these you choose to use. So the sum is equal to u1 times our common ratio to the power of the number of terms minus 1 over the common ratio minus 1. So let's start with example 1 here. We've got a series, 2, 6, 8, 54, all the way up to 12 terms. So what we need is our first term, u1, is 2. Our common ratio here is going to be 2 to 6, 6 to 18, 18 to 54. It's going to be 3. I'm multiplying by 3 each time to get to the next term. And my n value, the number of terms I'm looking at, is 12. So plugging that into my formula, I end up the sum of the first 12 terms equals u1, 2, times r, which is 3 to the power of 12, our term number, minus 1, all over r minus 1, so 3 minus 1. So simplifying that a little bit gives me 2 times 3 to the power of 12 minus 1 over 2. I have a shared factor of 2 in the numerator and the denominator, so those cancel out. And I end up with 3 to the power of 12 minus 1, which gives me a really big sum of 531,440. So if I took the first 12 terms of this sequence and added them together, the sum would be 531,440. All right. The second question is not asking us to find the sum. It's asking us to find a general formula, Sn, for the first n terms of this particular series. So we still need the same pieces of information. u1, my first term, is going to be 9. My r value may not be immediately clear, so we might have to use our old trick of taking a term and dividing it by the term before it. So negative 3 divided by 9 simplifies to negative 1/3. I can do the same thing with my next set of terms, 1 divided by negative 3. And that's the same thing as negative 1/3 as well. So my r value is going to be negative 1 over 3. Unlike the last example, it's just asking me for a general formula. So I don't need to know what n is. N can just stay as n. So setting this up, I end up with Sn equals u1, 9, times r to the power of n, so times negative 1/3 to the power of n minus 1. Notice that I'm putting my brackets here because my r value is negative. I'm raising that whole thing to the power of n, including the negative. So I've got to put those brackets there. And all of that is divided by r minus 1. So negative 1/3 minus 1. I could leave it like this. Might not be a bad idea to try to clean it up a little bit. So I can't do much to my numerator as it stands. 9 over negative 1/3, 9 times negative 1/3, to the power of n minus 1, all over negative 1 subtract, or negative 1/3 subtract 1. So negative 1/3 subtract 1, I need to have a common denominator there. So that's the same thing as negative 1/3 subtract 3 over 3. So the same thing as negative 4/3. So my new denominator is negative 4 over 3. And this may be a bit of a throwback for some people, but when I have a fraction divided by a fraction, I keep my numerator the same. And I multiply by the reciprocal of my denominator. So I'm multiplying by 3 over negative 4. And I end up with 9 times 3, which is 27, times negative 1/3 to the power of n minus 1, all over negative 4. And I'd probably move that negative up into the numerator. And here is my general formula for the sum